So the question is, how can you identify dojis as a bar direct with a bar direction, right? So with the bar direction solver, we can easily identify the direction of the bar when it has a body like so, right? When it has a body like so, it's pretty easy. And so the question is, if we have a doji like that, how do we find the bar direction for dojis when the open and close is at the high of the bar, or if the open and close is at the low of the bar? And so this will be a pretty simple one here. So I'm going to start working on the logic board here. So let me just start a new logic template, and all right, so we're looking for the bar direction of dojis. So I'm going to grab a bar direction solver, connect that up, and as we look at the chart, right, we can see with the default settings of the bar direction solver, right, the default settings here, that these dojis are not identified as having a bar direction, right? We can see the output is missing on those bars there. So the key here is the minimum bar size. Right? So we have this minimum bar size, and it's set to 1 tick. So dojis don't have any bar size, or they don't have any body size, right? So if we set this value to 0, then we can see that these dojis now are identified. And let's see here. Wow. Shoot, it's identified in the wrong direction. At least for the up doji. Yeah, hold on a sec. Let me refresh that. Well. Not sure why that is. Let me look through the chart here. Let's see. This is oil. I wonder if it's because of oil. I'll explain in just a moment here. But I'm going to find that other doji back here. Let's see. No. Yeah, that's identified wrong as well. Okay. Well, all right. So that did not work as expected. So let's do another route here. So there's more than one way to skin this cat. So let me get BloodHound open, and we'll go back to our logic board. And this time, I'm going to use a comparison solver. So the comparison solver, we can look at the price of the bars. So we're going to set input A to price, and we're going to set input B to price as well, just like so. And so when we look at these doji bars, let me stretch the bars out again. All right, what's the one thing they have in common? Well, on a down doji, the close of the bar equals the low of the bar. And on a up doji, the close of the bar equals the high of the bar. Right? So for a long doji, such as this, the close of the bar is going to equal the high. Right? So in input A, we have the close price of the bar, and down here in input B, we're going to set this to the high of the bar. And then let's set up the correct price for a down doji, for a short doji. And so that's the close equals the low of the bar. So for input B, for price type short, we're going to use the low price. All right, so when the close equals the low, then that's going to be a short doji. And now the next thing is we need to change our outputs here. Right, because input A, right here, input A is not going to be greater than input B. Right, they're actually equaling each other. So the close of the bar equals the high of the bar, or the close of the bar equals the low of the bar. So we're going to use the A equals B component here. Set that to 1. And the same for the short output. We're going to set this to 1 as well, and then set the others to 0, like so. And there we go. Now we have the dojis identified correctly. So let's take a look. And here we go. Here's another up doji. And let's look back here. Yeah, here we go. So here's another dragonfly doji. And oh, there was another one right there, another dragonfly. And another dragonfly. And let's see if there's any gravestones along here. I don't think there were. There's one more gravestone or down doji right there. There we go. Okay, so we did some spot checking of a few, and it all looks good. So let me go back to this kind of cluster of the two I had before. There we go. Okay, so there's two right there. Let's focus on that. So let's see, I don't see any questions coming in, so I'll just kind of take this one step further. So let's see, let's get this bar direction solver out of here. Delete that off the list of solvers as well. And let's give this a name here. This is going to be like a range bar direction. That's basically what this comparison solver is doing. It's telling us the direction of range bars. So yeah, so let's I'll just come up with a follow-up question here. Let's say we only wanted to identify these dojis, right? And so the rest of the bars, right, all these other bars that have a body like this, let's say we wanted to exclude those from BloodHound's output, right? So we don't want any output here when the bars have a body. So we want to isolate and look for dojis only. So the next kind of comparison we can do, so to figure out, well, what makes a doji, well, the open price equals the closing price, right? So if we look for bars where the open price equals the closing price, then that will isolate these dragonflies and gravestones. And so all these other bars here that have a body, clearly the open does not equal the closing price, so we could get rid of these that way. So we're going to grab another comparison solver to do this, and we'll check to see if the close price equals the open price. So let's connect this new comparison solver up, and let's give this a name here. So just checking to see if the open equals the close. So, all right, so again, we're going to set the type here to price, and we can see the closing price is already set up for us by default. And down in B, we want to set input B to the open price of the bar. So let's change our type to price again. And then the prices, we're going to change these prices to the open price. And again, we need to change our output so that we're using A equals B. So we want to know when A, which is the closing price, equals B, which is the open price. So we want to know when the close equals the open. So there we go. For long output and short output, we're going to use A equals B, like so. And turn off the others, set the others to 0. Okay. And there, shrink the chart up so we can see these dojis on the chart are identified by that one solver. So then the next step is we'll connect those two together with a AND node. All right. So there's the bar direction. And if we connect in this second solver, now we can see we've isolated the dojis only. All right, I think that kind of concludes this question. Is there ever a reason to use -1 in the output? Let's see, in the output A crosses B dialog box. That sounds like the crossover solver, I'm assuming. So, all right, let me let's take a look at that. Well, I guess let's just talk about outputs in general. Yeah, I'll start a new logic template here. So let's just grab any kind of solver. Doesn't matter. I'll grab a comparison. I'll grab a crossover. I'll grab a inflection. And you'll notice every solver has an output. Has an output section. So we're looking at the inflection solver here. All right, we're looking. Excuse me. We're looking at the inflection solver here. All right, so it has an output section. So here's the crossover solver, and it also has an output section, and the comparison solver also has a more elaborate output section. So it has a long output section and has a short output section. So the comparison solver is a little more complex than the other two solvers here. So it has a more elaborate output section. All right. So talking about outputs in general, I'll use the inflection solver here because it's very, very simple to understand. And let's just look at the inflection of price. All right, so let's see. Let's change our input type here to price. So when we're talking about output, the output here, really ultimately what we're talking about is BloodHound's output. And you'll notice that for these long signals, BloodHound's output equals 1. Let's shrink back. Yeah, here we go. So we can see BloodHound's output equals 1. We can see the little flag there is up on a 1. and right for a long output. And for a short output, right, for shorts, the output value from BloodHound is a -1. Now, this short output value is automatically, it's reversed by BloodHound on the chart. It's reversed automatically to a -1. Right, it'd be a little confusing if short outputs also had a +1. So just for visual representation, when BloodHound outputs to the chart, it's going to take the short outputs and convert them to a -1. Right, but we can see in the solvers here, the outputs are always using 0 or 1. Right, even if I go to, say, like the comparison solver, the short outputs are always a +1. Right, so this +1 for the short output is being converted to a -1, automatically when it outputs to the chart here. Now, basically, BloodHound operates with values ranging from 0 to 1. 1 being 100%. Right? So BloodHound is actually designed to use fuzzy logic. So if I wanted to, for this inflection solver, if I put in 0.5, right, that's 50%. And so we can now see, if I shrink the chart here, right, we can now see the output has been reduced to 0.5 or 50%. So when the output is 1, that's 100%. So it's considered 100% confidence. So, so the question is about, would you ever use a -1? And the answer is no. You can put, actually most areas you should not be able to use a -1. There might be a few solvers where a -1 is allowed, and the question was on that one there. Yeah, so a -1 is allowed, but that's just a little bit of an oversight. That actually should get reduced back down to 0 on that. And yeah, so on the crossover we can see outputs are negative numbers are allowed, but they're really not going to get used here. And let's see, yeah, so on the inflection solver, it looks like negative values, have been fixed, and they've just been taken the absolute and and converted back to a positive number. And for the crossover, it just looks like the same logic hasn't been applied to the outputs here of converting it back to a positive value here. But the short answer is the values that you use for the output should range from 0 to 1. 0 being 0% confidence, 1 being 100% confidence. Right, and that goes in line with BloodHound's output. So BloodHound's output, BloodHound's output ranges from 0 all the way up to 1. So, when there's no output, then there's 0% confidence that your condition is being met. So let's take a look at this inflection solver here. So in this area over here, so these bars, right, there's no output, right, the output is 0. So there's 0% confidence that price has made an inflection, or that price has reversed, right? There's no reversal of price within this area here. right? And we're looking at the closing price. We're not looking at bars. So remember, the inflection solver is looking at the closing price only. It's not looking at bars. All right. So in other words, don't get confused by looking at these bars. It looks like these bars are reversing direction, but we're not looking at bar reversal. The inflection solver is looking at the closing price. So a better way to see, a better way to see the closing price is, instead of looking at bars, let's look at a line on the closing price. And let's change this to something we can see. All right, so there we go. So the orange line represents price. So we can see in here, right, price has not changed direction until we get over here, and then price reverses down and then it reverses back up again. So that's when we're getting, so when price reverses down right there, so right there where price reverses down, right, we have BloodHound's giving us an output of 1 or -1, so it's 100% confidence that price made a reversal down. There's 100% confidence in that. And then on the next bar, right, price reversed up now. So right here we can see price reversed up, and then BloodHound's giving us a output of 1 on the long side. So there's 100% confidence that price made a reversal up. Right. So the inflection solver really isn't a good solver to demonstrate BloodHound's fuzzy logic, because when either you have an inflection or you don't. That's kind of that's an absolute kind of condition, yes or no kind of situation. But with comparison solvers, you can have a large amount. You can have these differences, these distances or differences between input A and input B, and you can see we have this gradiated output, and so you can really kind of get into fuzzy logic as to how close is input A from input B, and you can kind of get this kind of confidence level. Is input A 50% within range of input B? Or is input A, exactly, or does input A, has it reached input B completely 100%? So the comparison solver is a little more suited for fuzzy logic, whereas the inflection solver isn't. But so let's see. Let's take a look at the crossover solver, and let's see, on my chart I have an SMA 10 and EMA 55. So let me change the inputs here to match what's on my chart. So there's an SMA 10 for input A. I switched that to the SMA 10. Input B here, I'll switch that over to the EMA 55. And let's see, let me switch my chart back. And I wish Windows would remember my settings here. Excuse me. Yeah, there we go. All right, so if I use the type, it'll remember my color settings. Great. All right, now let me just fix the plot thicknesses here so we can see those. So we can see those EMAs or moving averages on the chart. All right, so I adjusted the crossover solver so we can, see all these crossovers of the moving average here, like so. So let's go back to the crossover solver here. All right, so let's change the name before I get going too far. So it's the SMA 10 crossing over the EMA 55. All right, so right? So we can see we've got a -1 in there, you know, but it's not changing anything. So even though it's displaying as a -1, it's not affecting BloodHound's output. Right, so I mean this short cross down is still staying as a short cross down, right? Regardless if I use -1 or 1, right? BloodHound's output is not changing. So internally, if you put a -1 in there, internally, BloodHound's converting it to a +1. It's just not showing it, you know, on the parameters panel here. So, yeah, but again, you know, yeah, there's no -1s aren't actually used for the outputs. Let's see, you can use a larger than 1, and let's see, and yeah, so that's not really being yeah, some solvers allow a larger value than 1, so you can put a 2 in there on some solvers, and you'll see that on the output, but really internally, let's see if I can find a solver here that allows a larger number. No. I'm just going to set this comparison solver up so that I can get an output here to play around with. And I'll just make it match the 2 moving averages on the chart. Okay, let's see here. Yeah, see. I'm not, alright, so I guess it's not none of these 3 solvers really accept an input larger than 1. It's just going to round it back down to 1. But you may find some of the other solvers allow you to put a larger value in there, and it will affect BloodHound's output. Will go to 2. You know, but again, that's there's no practical use for that if you do that. The only practical use, you know, for BloodHound is that your output values, you know, range from 0 to 1, right? Just the same as how BloodHound's output ranges from 0 to 1. Right? So you're not going to get anything special by trying to, you know, increase the value to 2, you know, or 3 or 5. So nothing special is going to happen when you do that. All right, I think that's probably really all I can kind of cover. Let's see, so the question is, we're going to take the doji. Let's see, so we want to take a doji regardless of the bar direction, I guess regardless of the doji direction, and use it as a entry trigger in the direction, say, of the short-term moving average. All right, yeah, we can put that together. So let me find a spot on the chart here that kind of illustrates that. Let's see, let me just start a new logic template here. Let's see what to call this. All right, so doji entry in the direction of the moving average. Something like that. All right, so let me find some dojis again here. I erased all my circles earlier. here we go. There's one. Actually, I could do this faster here. Let's mark them. Oh. Okay, so we have a handful of trigger points on the chart marked. You know, got our dojis marked. And so now we got something to work with on the chart. Okay, so let's connect that back up. All right, so let's switch over to our new logic template here. All right, so yeah, first thing we want to do is identify dojis. And let's see, so on range bars, we have, we can use the open equals the close, right? We can use that comparison solver. So on range bars, right, it's pretty easy to identify dojis here, because the open equals the close price. All right, so let's scroll down. Yeah, okay, there's a few more. There we go. So all these dojis are marked, and you'll notice we're getting a long and a short output from BloodHound, right? Long and a short output from BloodHound, and that's what we want. So, because the second part of the question is, we're going to take we want the signal, the entry signal, in the direction of a moving average. So we'll just use this SMA 10 since that's already on my chart here. All right, so this would be a long, basically this doji would be turned into a long signal, and this doji would be turned into a short signal, and this doji would be turned into a long signal. All right, so so we have this comparison solver is giving us a long and a short output. So the next component is, we need to look at the direction of our moving average. So we want to look at the slope of our moving average. So we're going to grab a slope solver, like so. Let's connect that up, and let's rename this here. So we're going to use the SMA 10 in this example. And so let's go down here and adjust our indicator value. So let's put in a 10 period. All right, so if we look at the chart, there we go. We can see we're getting a short when the SMA is sloping down, and we're getting a long output when the SMA is sloping up, like so. All right, so now we just need to combine these two together with an AND node. All right, so there's just that's just the raw doji output there, and then we can connect in this slope solver, and that will filter out the direction. The direction of the signal. Yeah, direction of the signal. So this doji, produced a long output when the moving average is rising, and this doji, produced a short because the moving average is falling. And here we go, there's a couple more back here as well. So we have a couple of dojis, 3 dojis, but our SMA 10 is falling, so they're converted to a short output there, short trigger. All right, let's see if there was any follow-up questions on this. All right, so the question is, let's take this, this set of logic here that we just built with these kind of doji signals here, and we'll plug them into Raven. So, all right, so let's close up BloodHound. So, closing up BloodHound, right, saves our work back to the file. And then next, let's pull up our strategies and pull up Raven. All right, so with Raven, we're going to scroll to the top here and just start from the top and work your way down. And so let's load up today's BloodHound file. So there we go. There's today, April 20th. Load that in. And let's go find the logic template that we'd like to see on the chart. So the doji entry in direction of the moving average. So that's the one that we're interested in. So we'll select that one. It's always a good idea just to make sure that all the leaders look like they're connected correctly. So it's always good just to do a quick little check, make sure things look correct. Because with BloodHound, it's pretty easy to accidentally leave something looking like that, right? As you're kind of doing some testing with your, as you're building your BloodHound system and testing everything, it's fairly easy to leave the wrong thing connected to the result node. So it's always good to take a quick look like that. So, all right, so we have our logic template selected. We've looked at it. Click OK. And then the next thing is let's decide, which logic template is used for the entries. So let's go down here. The doji entry is the one that we're looking at. And then next thing is, set yourself some profit targets or stop losses if that's what you use within your system. And I'll just set up something real simple. Just do 10 and 10. I'll do a simple 10 and 10. Let's see, just so we can see some examples on the chart. I'm going to turn the Start Auto Enabled on. I'm going to set this to true. And you'll see that opens up backtest mode, which is set to true. Sorry. So with Start Auto Enabled on set to true and backtest mode set to true, then we can kind of see the executions on the chart. It'll just give us a nice visual. NinjaTrader will give us a nice visual on the chart. Oh, and I forgot to do the last step. So whenever you're working with strategies, always remember the last step is to enable your strategy. Turn it on there. All right, just double checking all the settings, make sure nothing changed and all looks good. All right, click OK. And so, yeah, there we go. So now we can see the historical executions on the chart there. Yeah, I'm just kind of pointing something out here about Raven. So you'll notice that it looks like there's two BloodHounds on the chart. So you can see one of them is labeled BloodHound, and if you look at the other one, you'll see it's labeled Raven. Right. So this BloodHound, this output of BloodHound actually came from Raven. So Raven placed this BloodHound output on the chart there. And you'll also notice that, right, there's a BloodHound button right there that's black. So it's got black text. And then you'll notice there's another BloodHound button right here that has orange text. So that orange text identifies Raven. So this is the Bloodhound that's running inside of Raven, whereas the black text, that's Bloodhound running on the chart. So this Bloodhound, which is running on the chart, which was added to the chart directly, that's going to be the black text. And then when we loaded up a BloodHound template in Raven, Raven then added BloodHound to the chart as well. And so therefore, that's what the orange text is. This is the BloodHound running inside of Raven, and that would be this panel down here is the BloodHound running inside of Raven. And so you can tell by the label there. Is there a way to detect what bar type is on the chart? Yeah, so you're referring to the bar type. Here, let's open that up here. So, or actually, technically, NinjaTrader calls it the period type. Yeah, so is there a way to detect? Let's see. So the question is there a way to test what period type is in effect in BloodHound? You would need a custom indicator to read that, right? So BloodHound is not the type of indicator that detects what bars are on the chart. So that would require a custom indicator to read the chart and then return some kind of value, so the custom indicator would output some kind of a value, like say a value of 1 for a minute chart, a value of 2 for a tick chart, value of 3 for a volume chart, something like that, just as an example. You create a custom indicator that would output various numbers depending on what the period type is, for BloodHound to read. So Frank has a private comment here, guys. So Frank is saying, so it seems like having BloodHound test for what bar type BloodHound is running on would be valid because it might affect what solvers that you're using. That's definitely a valid statement. Some trading methodologies, don't work on some bar types. Some trading methodologies, really would run efficiently on a minute chart, but they wouldn't work very well on a range chart. They may not work well on Renko charts. So having a way to detect the bar type, that I'd say it's a valid statement, but at the same time, that's not what BloodHound's about. That's what the custom indicators are for. It's like once you start going into that realm of, well, it seems like BloodHound should detect this and that, then pretty soon everybody wants BloodHound to detect their own custom stuff. But that's exactly why BloodHound can use any indicator out there, right? So whatever kind of custom need you have, you just create your own custom indicator that addresses a need that you have, to do that automatic stuff. But at the same point, at the same time, if the user is building the BloodHound logic, and so the user should be fully aware of what chart types the BloodHound template was designed to work on, right? So if so let's say this is a doji, right? So this logic template, since I built it, I should know that this was only designed to run on range bars, and so I should be using my own intelligence to make sure I'm not running this doji thing on a minute chart. You know, so there is definitely some user responsibility when it comes to knowing which templates run on what chart types as well. So, you know, if you really are, you know, needing to build something more automated, so that the customer doesn't, or the, you know, the user doesn't have to think about, you know, what bar type that is on the chart, then again you're kind of getting into a custom need, a custom automation kind of need, and yeah, and then that kind of gets you into, you know, building or creating a custom indicator for that. Yeah, you know, so we're speaking hypothetically here. You know, if we did have a custom indicator that would identify, here, let's work on a new logic template here, and I'm just going to throw a bunch of miscellaneous solvers on here. You know, none of this is just for demonstrating a hypothetical situation here. All right, so let's say, you know, so if you had this bar type kind of finder indicator, and you're, you know, depending on the bar type, you had three solvers here, three solvers that you were trying to figure out, you know, which one of these to use, you know, which one of these three to use based on, you know, your bar type finder. Let's see, there's a couple ways we could do this. Let's see. A simple way to do it would just be, you know, using some and logic. All right, so you know, I'd take a threshold solver. You know, you'd have to plug in your custom indicator in here, which we don't have, so we're just going to speak hypothetically. You know, let's say range bars are, you know, range bars are identified as number 5. So I would set up. My solver like this. So I would find, right, so I'd set B to a threshold of 5, you know, which our theoretical custom indicator would, you know, output a value of 5 when it has detected range bars. And so I'd do something like this. So I would have a long output at 5, and then a short output at 5 as well. And so let's see. Yeah, so here's a solver that says range bar direction. And so coupling those two together with an AND node. And I'll need an OR node coming out like that. Right, so this is kind of how you would set this up here. And so let me take our threshold solver. I'll make a copy, and so So let's say we want to detect a minute bar, and I'll just say that let's say minute bars have a value of 1. So a minute bar is going to be a value of 1. So I'll set my threshold up like this. So I'm trying to identify just a value of 1 only, right? We don't want any values greater than 1. So that's why I have this, right? Greater than 1.1 is set to 0, but at 1 is set to 1, and at 0.9 is set to 0 and 0, 0. And then let's see, let's just set up a third option here. Let's say we want to identify tick bars. So let's say our custom theoretical indicator detects tick bars as a value of 2. Then I'd go like that. All right. So we have a threshold solver created for every bar type that's needed to be detected here. And so next I would drop those on. Let's drop these on the board here. Right, so so here's kind of a logic a logic diagram here of how logic diagram showing that if you needed different solvers or different solver settings for different bar types, that's how you could get the logic to automatically use the correct solver based on the bar type that BloodHound is running on, something like that, right? So this solver and this one is theoretically detecting the bar type, and then these solvers would be the correct solvers to use with each of the bar types. All right, so you just join them together with an AND node and an OR node. Really, the ideal thing to do is, if you have different logic, there are different solvers that are ideal for certain bar types, then the best thing to do is to break out, create a different logic template for each of the bar types, and then of course just clearly label your logic template here. So if this logic template is useful for was designed to be used with the minute bars, just definitely put that in the name of your logic template to help, just as a reminder that this logic template should only be used with minute bars, or range bars, or whatever the deal is, right? Just put the bar name in the logic template name. Right? That's kind of a good naming scheme. And also remember, you have a description area, so you can just put a description in there. So you can use the description area like so as well. Just also add some more add some more reminders to yourself, as to what what these logic templates are for, right? So all right, so I can put a description for this Doji entry, right? So something like that, right? So, yep. It's always good to use these descriptions, right? Because BloodHound makes it very simple to just start whipping out a whole bunch of ideas and templates and logic templates and BloodHound templates, and without putting a good description in here, it's quite easy to forget something that you've done a month ago. So definitely keep using these description areas here. And then you also have a kind of a master description area up above here, so something like that, right? It's kind of a master description, and then you can put individual descriptions for each of the logic templates there. Just something to jog your memory. All right, well, gentlemen, have a good rest of your day. If I don't see you in tomorrow's Blackbird workshop, then have a great weekend. All right, hope to see you next week. Bye-bye, guys.